That's all trig. Trying to find logs. Okay, there we go. Solve. Which formula am I meant to use first? Log 3x minus 4 subbase of 2. That's annoying.
ln 3x minus 4.
Yeah, change of the base. You can't use that 2. You don't like the 2. ln 3x minus 4 over ln 2. Now you're just dealing with fractions. So what do you do with this log 2? You're just dealing with fractions. Times it across to the other side. Now you're here. Log 3x minus 4 equals 5 log 2. Then I said, before you're allowed to exponential, these can only be monic logs. That means no numbers in front. What do you do with the 5? Bring it up as a power. Now what do you do to both sides? Technically, which means you can cross out your logs, exponential, and we're pretty close. 2 to the power of 5 should be 32. And then you're done. 37 on 3.
Will I get 3x minus 5?
Oh, that's because I don't know how to read. Just so you guys know, it's a good one to know. This is called a transcript error. Full marks. So if you just did a transcript error, if you made a 4 into a 5, you haven't made the question any easier. That's very important. You haven't made it any easier. This, you've made it easier. Let's say, because we assume people know how to plus, but they don't know how to subtract. So with changing a minus to a plus, you've made the question easier. That's not a transcript, but if it's just a number like that, that's called a transcript error. You actually get full marks. So it's just good to know.
Plus and minus.
What is it?
Plus and minus.
No, if it was a plus and you made it into a minus, you'll get full marks because you made it harder. Because the minus is harder. But if you made a minus into a plus, you will not get full marks because you've made it easier for yourself. Plussing is easier than subtracting. That's the logic that we have. Who knows if that's the right logic, but that's the logic. 3x take away 4, that's 36. 36 on 3 should be 12 now. Yep. Is that right? We hope. Okay, move on. Just one thing you've got to know with these, always check with logs. But if I sub in 12, it's going to be giving me log of 36 take away 4, 36 take away 4, which I know is positive, so it's fine. The only problem you will have is, imagine you solved for x is 1. Imagine you did all this and you got x is 1. Well, 3 times 1 is 3. 3 take away 4 is negative 1. You can't log a negative. There is no solution. You have to be aware of that. So mathematically it worked, but it doesn't work through the definition of your log. So I should say algebraically it worked. Mathematically it didn't work. So you got to be careful with that. With logs, whenever you're solving, always check. That's all I can tell you. All right. That's trig. That's another trig. Not for you. You can see there's probably only going to be one log question. That's not really functions. That's linked coordinate geometry. Okay. All right, there you go. There's another exponential equation. Solve the following equation for x. How do we do these ones? It's a quadratic. That's what I like, those instincts. If you've studied, you know it by just looking at it. There you go. You can let u become e of x, then becomes a quadratic. Factorize, solve. I'll leave it with you guys for a little bit more. Here we go. U plus 5, u minus 2, u equals negative 5, u equals positive 2. That means e to the x equals negative 5, e to the x equals 2. You know your exponential can never be negative. But anyways, if you log both sides, can you log a negative 5? No. So both ways, you should get no solution there. This one here, what are you going to do to both sides? Of course, log. What are you left with? X equals log 2. That's the only answer. Guys, got it out?
Yeah.
Good work. Any questions? Okay, let's do some more. Logs, any more. That's tangents, functions. Yeah, well, we'll do this. We won't do any of it the way it says it here, because obviously that's next year. What we'll do I. I'll just make them up for you. Double I would be, for find that equals to 0, double I will be sketch. Yep. I find all the solutions for f of x equals to 0, so solve. Double I, sketch. I'll leave that with you guys. I'll be right back. Did you guys solve I? What did you get?
I got -3 and 3.
-3 and 3. Sounds good to me. Were you able to sketch it? Nice. Let's see. Okay, for I, of course, x plus 3, that becomes a difference of two squares. X plus 3, x minus 3 equals 0. Doesn't matter if you didn't do it like this, as long as you got your answer as -3 and +3 for I. The reason why I did that was because I know I need it for double I. What you need to realize is f of x is x plus 3 all squared with x minus 3. So it's a cubic. So your whole polynomial is x cubed. It bounces here, bouncy, and it cuts through here. So the answer would be cubic start down here, bouncy at -3, cuts through at 3. So start down here, bouncy, cut through. No, Tiana didn't get it out. Did you just do it as a parabola? -3, yeah. I know, that's where the factorization skills comes in. You got to learn, once you see that difference of two squares in there, to think of it as factorizing, and then, yeah. Anyone have any issues with double I? Or it feels like they don't know something that we just did there? X cubed, bouncy, cuts through. And then, of course, to work out this number, you let x equals 0, you should get -27.
X cubed, you said, because the highest.
So x cubed, I said, because what's the highest power of this expansion, this bracket, first bracket? What's the highest one? X squared. Multiplied. What's the highest of this bracket? So whenever you're going to expand all this without expanding, but when you do expand it, what's the highest power you're going to get? X cubed. And that's how we look at it. So again, if I gave you something like this, what's the whole polynomial? What's the largest power of your polynomial for this one? X to the power of 4. You get that? Without expanding. But you got to think of it like if you had expanded, what would have eventually happened? The highest would have been x power 4. So therefore, that means you're going to start up here. Because x positives, even positive powers, you start up here. And then cut, bounce, cut. Cut at -1, bounce at -3, and cut at 2. So bounce at -3, cut, cut. Bounce at -3, come back down, cut through it, come back up, cut through it. Make sense?
James,
Yes.
can we do more stuff on graphing them?
More stuff exactly like that? Those kind of graphing?
Yeah.
Yep. Yes. Anything else right now? No? All right. More on those kind of graphs. Let me see, so we don't miss anything then, in that case. Let's open up your actual Year 11 Advanced Functions. Let's open up that one. And let me open up this one. You guys remember this booklet? A long time ago now. Oops.
Was if we gave us last sheet.
Yes, exactly. Hyperbolas. All right. I guess I'll start it somewhere here. Oh, so much. All right, that's pretty much where it starts. All right, let me see if I can find any in here. Odds and evens, domain and range. Okay, let's do that one. These exemplar questions, exemplar meaning pretty much full mark questions or perfect questions. This is from NESA to teachers. I'm not sure if students had access to this or not, but anyways, to teachers to say that pretty much this is what they'll get in their HSC exams. So if your students know all of these, this is pretty much what we'll ask of them. Just so you guys are aware. If I ever give you exemplar questions, that's the way these work. These are specifically from NESA saying all students need to know this because this is what will be in their exam. All right, but we know that anyways because I say that to you. X minus 1 cubed. Can anyone remind me what we do with a cubic? If it's all cubed like that? So we said powers of 1, we're cutting through. Power of 2, we bounce. Power of 3, that was another funny word. Squiggly. I use that word so that you guys don't forget it. All right. Let's go. What's the highest polynomial? X to the power of 4. So we're going to start at top left.
If it was negative x to the power of 4, it would be
Negative x to the power of 4. You'll start bottom left. Just like where would you start with negative x squared? That's the idea. So negative even powers, you start at the opposite. Yes, good job. All right, back to it. Starting here, negative 2, cut through, 1, squiggly. Negative 2, cut through, squiggly. Easy?
So dumb. No one will ever use this.
True. This one here, not really used. Yeah, not used in this sense. It's used, like, for example, I don't know, right now with the whole pandemic and everything, they use obviously modeling, so equations, and then they graph them to understand how it all works. So it is used actually, but you've got to know how to use it. And it's got to be your field. Like if you're not going to get into predicting models, so like doing some sort of econometrics or statistics, yeah, you'll never see it again.
But when will anything dip below 0?
Now you're looking at maybe weather cases, so like temperature. You're looking at money. I guess the application is different.
Yeah.
You're definitely not looking at, so you're saying below 0, you're not looking at obviously numbers of people, if we're going to talk about that, but what you could talk about in negative would be the rate that let's say a virus is killing people. If the rate is negative, well, that means it's not killing people now. And that's what you're trying to do. So sometimes you might hear they want to go below 1 or below 0.5 or what are those numbers? That's because then at that stage, it's getting closer to that 0 or below 0. And below 0 means that we're on top of it instead of it being on top of us. So something like that. But like I said, you got to understand it.
Yeah.
So a lot of the stuff that you guys are doing, you're doing very at a very elementary level. Very, very elementary. But I agree. Look, for those who are in extension 1, they use perms and coms, which is probability and like choosing and stuff like that, in animation. Like graphic designers actually use permutations, combinations. What they'll do, for example, they'll draw 3 different heads, right? Whatever. And then they'll use 2 different bodies. Let's call it this. Then they'll use 3 legs, whatever the legs are. There you go. And then from that, you'll be able to get 3 times 2 times 3. 6, 18 different robots. And all you had to draw was 3 faces, 2 bodies. I'm saying it's used, but you'll only ever use it specifically for the job that you'll eventually get into. I know that, for example, I know that they use half parabolas this way, concave to the side, to draw grass in animation again. So instead of them drawing thousands of grass, because no one's going to do that, what they'll do is draw y equals root x, which looks like this. That way, exactly that. And then they'll just extrapolate that 1,000, 1,000,000, 20,000 times, 20 million times, and you pretty much have grass. So it's used, as that's all I can say. But yeah, you were going to say something, sorry?
When it's powered to 4, it would be like a bounce here because it's an even number.
Correct.
Okay, yeah.
Correct. So pretty much the way it works is this. Any powers of 1s, 1, 1, cuts through. Any even powered 1, individually, right? We're talking about individually, not the whole polynomial. Individually, any even power, bouncy. Any odd power other than 1. Any odd power other than 1, squiggly. The only other thing you have to remember is the whole polynomial.
So it's like,
Whole polynomial, yeah, starting point. If it's x, x cubed, x5, etc., you start down here. If it's x squared, x4, x6, just like any other even-powered parabola, that's how I think of it. Cubics start down here. That's how I think of it. So that's how I know it's there. X squared, they start here. And if you did negative x squared, negative x4, they start the opposite way. The same thing as this guy. Negative x cubed, negative x power 5, and so on. Cool. Should we do one more of these? F of x equals 2x minus 3, x minus 2 to the power of 2, and 3 minus x. There you go. That should confuse a few people. Oh, well, we'll make it 3 plus x, just to make it a little bit nicer with the way, otherwise we're going to be too close to each other. All right, try that. Okay, what's the highest polynomial? X to the power of 4. I just want to make a quick point. Unfortunately, I changed it. But if it was 3 minus x, I changed it only because obviously they would have all become positives and that would just be annoying to draw. But just have a look. This is an x times the highest here is x squared times the highest here is. So this is actually negative x to the power 4. So this was the one you would have started on the opposite way. You would have started down here. All right, so just be careful of that. Otherwise, you don't need that right now. For this question, we had it as a plus. Okay, and then x to the 4, start up here, cut at -3, cut at 2, and at 1.5. Ugh. 1.5 and 2. Should look something like this. And then this one here, if you want to work that out, that's -3 times 4 times 3. Just sub in 0. -3, 4 times 3. -24. Wait, what? 9. 9 times 36. Can't multiply anymore. All right. Done. Move on. Move on. What about this one? Sketch this one. Number 2. Y equals 1 on x take away 3. You have to show all asymptotes and intercepts. So sketch y equals 1 on x take away 3. Showing intercepts, asymptotes. Yep, that's it. Can someone tell me what this obviously is? Hyperbola.
Oh, I know the shape. I just get confused.
Hyperbola. What can x not equal to?
Less than 3.
0.
Okay. 0, no. That's for the generic one. For this one, what can x not equal to? 3. Yeah, because the denominator can't be 0. So this whole denominator can't be 0. So x can't equal to 3. And obviously this hasn't shifted up or down. So y cannot equal to 0. If you know your original one, which is this, you know this makes sense now because x minus 3 means shift it to the whole thing to the right 3 units. If you're going to move the whole thing to the right 3 units, you can see this asymptote, the black one here, is obviously going to move here. See? The horizontal, the flat one, is not going to change. That's going to stay as it is because it hasn't shifted up or down. It's shifted right. And then, of course, your black graph just all moves, right? Very easy. There it is. Nothing too difficult. Substitute. X is 0, you'll get y equals -1/3. Piece of cake. Very, 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 very easy.
Sam,
Yes.
what about when the bottom is all squared?
Yes, we'll do that now. I don't know if that's for advanced, but anyways, we'll do that. What if at the bottom was squared? And you got to sketch this. Sketch this. Okay, again, what can your x not equal to? 3. What can your y still not equal to? 0. Okay, so we agree with those. At least that doesn't change. So your domain and range hasn't changed. Now, what you've got to understand with it being squared is this thing ever going to be negative?
No.
So is the y value ever going to get to negative?
No.
So will this ever occur down here? No. So If you understand that, then this should be the answer. That, if I sub in x equals 0, I get 0 take away 3, which is -3 squared is 9, 1 over 9. And then instead of it being this way, which is the way you guys usually would do it, because it's squared, it makes it always positive. It does it like that. It flips it up. But I don't think that is in your syllabus, Alessandro. That sounds like extension 1. So that's specifically, I know the extension kids got to know it, but the advanced kids, no, that shouldn't be in your syllabus. But anyways, the logic is still the same. All you're doing is just making sure that it's always positive, I guess. Okay. Any other questions? Okay. Open this up. Oops. Let's go back to these functions. Okay, interval notation. I'm just going to scroll down. If you see something that you're like, yes, this is what I've completely forgotten, just stop me. I'm just going to scroll down. Interval notation. Domain and range 1 to 1. Right, the domain and range. Function notation, how to substitute the different function notations in. F of g of x, g of f of x. Like I said, stop me when you need to.
You go back to the f of g of x.
Don't worry about the whole draw function machine. That was back when you were in kindergarten. Now that you guys are finishing off end of year 11, you just do it. So what do you do for f of g of x? Sub in g of x into f of x. So it'll look like this. F of g of x looks like this. 7, sub in this guy into this guy. Whereas g of f of x, sub in f of x into g. Sub in this into g.
I got a question for like a mock exam once. It was asking f of x is even and g of x is odd.
Yeah, we've done that one.
Can you show me how to do that again?
Yep. You just pick f of x as x cubed and g of x is x power 4. That's even, that's odd, and then just sub in negative x and it should work out. That's my clue. I wouldn't do it so theoretically. I'm saying I'll just pick x cubed and x 4. Anyways, any questions? And then just expand. Hopefully we can expand this. But anyways, any questions? All good. All right, we'll move on. So that's more of those style of questions. Then you learned domain and range for all the different cases. Do you guys know? Yeah, domain is okay. Okay, let me know. Then you would have learned transforming, like what happens left and right, up and down. Okay, this one, find the center and radius. That one 100% will be in all of your exams. Do we know how to do that by now? Complete the square. Good luck. Quickly do it. It should only take you about one line if you're doing it my way. All right, here we go. If you've done it correctly, like I said, one line, x minus half of 6, y minus half of 4. You always bring your constants to the right-hand side, plus 9, plus 4, you're done. Are we there yet? What bit did you get stuck on? The halving bit or the constant to the right-hand side?
No, I just made a mistake. I accidentally put 6 instead of 3.
6 instead of 3, fair enough. Half. Halve it, square it. Anyone have any questions there? Your center is then positive 3, positive 2. Your radius is the square root of 9, which is 3, and then sketch it. X is 3, y is 2. Go up 3, 1, 2, 3, go up 3, go down 3, go to the left 3. Voila. Not a bad graph. I haven't touched here. I made it. That's good. All right. Any questions? 100% will be in your prelims, will be in your trial HSC, will be in your HSC. Yeah. Well, it's a guaranteed 3 marks. You can't say that for every topic, but you know that will be in it. So like 1-to-1, you don't know if that's going to be in it or not. This one, guaranteed. Anyways, move. Let me know, again, as always, if you want to do more, want to do less. Odds and evens. How do we prove something's odd? Sub in negative x. If it's negative of the original, it's odd. How do we show something's even? Sub in negative x. If it gives you the original, it is even. If it doesn't give you either, then it is neither. All right, test these functions. What's our first step? Always sub in negative x. What's negative x to the power of 4? It's x to the power of 4, which is the original. Therefore, even. Any questions? So regardless if it's odd or even or neither, you always start with the same first step. Step 1, sub in negative x. If it gives you the original, great. If it doesn't, you force out a negative. B, sub in negative. Is that the original? No, you force out a negative. Is that negative of the original? Yes, that's negative of the original. Therefore, C, what's step 1? Sub in negative x, f of negative x equals negative x squared minus 2 negative x. Is that the original? No, so what do we do now? Force out a negative. Is that negative of the original? No. So it's not even this guy, nor is it this guy. Therefore, so step 1, always sub in negative x. Okay. Again, let me know if you need more work on that. You can just scroll up. What else? Y equals mx plus b, that's part of linear. I don't know if you guys need work on this. Sketch. Yes, this one. That's very poorly done. Anyone remember how I taught this to do these style of questions? Because I did them in a very particular way.
You just get the graph out.
What do you mean by that?
So like from whenever x is less than 0, it'll be x squared.
Yeah, but the way I would have said it to you guys is draw all three of them
Oh, and then cross out.
and then cross out. There you go. You remember now. That's probably the best way to do it. I think your teachers usually cross out during the working out. I don't do it like that. I like to say just draw the whole thing. I've seen it being very successful for a lot of my students. So just draw each one and then cross out, not cross it out during.
Would we write like do not mark?
Yeah, you could write that. If you've done it in pen, just write do not mark. Y equals x squared. Here it is. Y equals 3x. Whoops. Y equals 3x. There it is. And y equals 12. There it is. Okay, and for x less than 0, 0 starts from here, and less than, it's the blue curve. Agree? Open circle. Let's use a different color than orange, so we don't get it confused. There you go. Open circle, why? Because less than 0 doesn't equal to 0. But when then after that it's the black line, but it starts at 0 and it goes all the way up to 4, not including 4. So again, at 0, 3 times 0 is 0, so now it works. So you don't have to have an open circle there.
And we open circle that.
And then we go to 4. Where is it at 4? At 4, 3 times 4 is 12. So actually, this black line will go all the way up to right there. Again, you said open circle, but then what do we know? This is also 12. So it goes like this. So it's actually meant to have open circles usually, but in this case, everything's connected. When everything's connected, does anyone remember what the name is called? It started with C. Continuous. So is this graph continuous? They would ask, is this continuous? You would say, yes. Is it differentiable? You would say, yes. Because it's continuous. It just depends on those particular points. Is it differentiable at these corner points?
Can we get a couple more of those?
You want to do a couple more? Okay. It very likely won't be continuous because I'm just making this up. Excuse me. Thank you. 3x squared, take away 3. All right, go. So for less than 0, it's this one. For greater than 0, or greater than or equal to 0, it's this. Try to see if you can draw that. Okay. My turn. Y equals x minus 1 would look something like this. X is 0, y is negative 1. Y is 0, x is positive 1. And draw a line. Cool. And the other one would be y equals 3x squared. Take away 3, factorize your 3 out. So find your x and y intercepts. Y is negative 3. Y is at negative 3, so somewhere down here. When x is 0. When y is 0, I can just say x equals to plus minus 1. So you'll have minus 1 and you'll have 1. And then it should look something like this. Oh, really bad. Oh my god, what even is that? Alright, let's go back. Let's make it a little bit more symmetrical. There we go. Okay. It's really hard drawing with this. There you go, minus 1, negative 3 to 1. Okay. Then we restrict. For x is less than 0, it's got to be the black line. For x is less than 0, which is from here, it's got to be the black line. For x is greater than or equal to 0, it's got to be the parabola. For x is greater than or equal to 0, it's got to be the parabola. So your answer looks something like this. Pretty much everything that I did in yellow, just open circle. See, it's a line from there. It's including that. And obviously this function is not continuous. It is not continuous. Is it differentiable everywhere? No, because there's a pause right there. Can you differentiate it at this stage? Yes. Only for x is less than 0. Can you differentiate it here? Yes. Only for x. Can you differentiate the whole function? No, because there's a pause. There's a break. There's a break there. That's not allowed. Okay. Any questions? Were you able to graph that?
Oh, I made a mistake with the x minus 1. I made it straight line instead of.
So diagonal. Straight lines are only if it's constant. Y equals 12, like this one. Okay. Move on. Absolute values. Then you would have learned these, which are just V in shape. X, move it to the right 2 units. Something like that. Any questions there? No, move on. Move on, move on, move on. Solving, then you got to quadratics, axis of symmetry, vertex. Find the roots, which means solve, sketching. Write down.
Is axis of symmetry negative b on 2a?
Negative b on 2a for axis of symmetry. Let's do that one. Find the equation of the following quadratic. So I just gave you a parabola and I said, okay, go find the quadratic. So what do we know? What do we have so far that we know? We've got our x-intercepts and we've got a y-intercept of negative 24. When y is 0, x is... Okay, cool. So technically, you already have y equals... How would you have got your x-intercepts? Usually, what would this have been written in? Yeah, correct, 0. So what form? Because there's a few different forms, isn't there? You can see it quadratic. You can see it like this. That's not general form. General form you're thinking of is a line, ax plus by plus c. Like that's I guess that's the general form of the quadratic, ax squared plus bx plus c. And there's another way that we usually would write a quadratic as well.
In brackets.
In brackets. That's all. You don't even need to say the letters. So if you know these are intercepts, they would have come from there. Does that make sense? What's the only difference between me writing this as the actual answer compared to obviously what's given here? Well, it's saying that my y-intercept should have been negative 24. I can see when x is 0, I get negative 8. 2 times negative 4. But it says it should have been negative 24. How do I do that? I'm going to get negative 8, but it says it should have been negative 24.
Normally has to be 3x.
Say it again.
One of the two brackets has to be 3x.
Oh, you're so close. You got the right logic. The problem with saying this is 3x, what happens now when you solve this? What do you get when you solve this bracket? Negative 2 over 3, which is not what you want at all, right? Because you know you wanted negative 2. You got the exact logic. Anyone see where I should put the 3? On the outside. Correct. Because now your intercepts are still negative 2 and 4, but at least that 3 adjusts this number here. And that's it. That's the graph. So that's one way, which is very poor way of doing it for these methods, or there's the second way. There you go. The bracket way. You'll only use probably this one if I gave you maybe the axe of symmetry or something like that. Then from there you might be able to get this stuff out. But anyways, that wasn't too bad. If you knew to start off like that, that's really important that you knew to use the brackets because of the intercepts. Completing the square. Here's another one. I see now I didn't give you intercepts. This is the third version. So there's 3 versions of parabolas. There was 1. There was now 2 when we gave it intercepts. And what's the third version? Say that again?
1 bracket all squared.
Yeah, he knows it. That's amazing. 1 bracket all squared. And then maybe plus or minus whatever, it's got to be constants. So like x minus 5, that means you shifted it. You shifted it plus 5 and then you went up and down, whatever. So you either know it the generic way, which doesn't really help much, the intercepts way, which helps a lot, or this way, which now you've got your turning point. Because if you can write something in this way, for example, I'll give you an example. Now you know that this parabola, the original parabola, shifted to the right 5 and up 2. Shifted to the right 5, up 2. See, look, you actually know your turning point now, just from this form. Whereas in this form, you don't know your turning point. You got to go and work it out. But you know the intercepts, and that's something you don't know with this method. So, all right. Yes, you do need to know that third version for this one here. Why? Because that's a turning point. We know that the x value is 3 and the y value is 2. Right? So I know it's sad. So I know straight away it's negative bracket x minus 3, because that means shifted to the right 3 units, squared, and then it would have been plus 2. Do we agree with that?
Why is the minus on the outside of the bracket?
Why is a minus on the outside? Because whenever it's negative x squared, it would be Sad. If I put the negative in the inside, what's a negative squared? Positive still. So that's why the negative is in the outside. Now, you're not done. What do you have to double check? Minus 16. This bit here. You specifically know that when when x is 0, y should be negative 16. When x is 0, y should be negative 16. So again, when negative, let's call it a, the number I'm missing here at the front, just like we did before. I didn't write a before because you guys could see 3 times 8 is 24. But let's say that was a, 0, take away 3 squared plus 2. That's 9, negative 9a plus 2 must give you a y value of negative 16. So negative 16 take away 2 is negative 18. A equals positive 2. As long as a is 2, so the answer is negative 2. As long as there's a number of 2 at the front, the y-intercept becomes negative 16. But look, I still have x minus 3, which means shift the whole graph to the 3 units to the right, and then plus 2, which means shift the whole graph up 2. Negative means make it a sad, and the 2 just makes it sharper, in a sense.
How did you get 9?
How did I get 9? 3 squared. So I'm saying, like, you can't change this number, you can't change this number, you're definitely not going to change the number in front of the x, because then that will change your intercept. So it's always the number in the outside to adjust. Okay? And that's it. That's all the 3 methods. 1, 2, 3. Number 1 you never use, but number 2 and 3. If you're given the intercepts, you use 2. If you're given the vertex, you'll use 3. Then you learn the discriminants. If discriminant is equal to 0, there's 1 root. If the discriminant was greater than 0, you got 2 roots, or distinct or unique roots. If discriminant was less than 0, we had no roots. Right? We remember all that? And what does discriminant stand for? B squared minus 4ac. All right. There we go. That's the question you'll probably see in your exam. Either one. Let's do this one. Find the values of k for which this has unreal roots. That means find it for discriminant being less than. Good luck. B, A is 1, C is negative this whole thing. That's C. I'll leave it with you guys for a second to try. B squared minus 4 times A times C. I'm just going to expand it at the same time. Less than 0. Less than 0.
What happens to that x with the k minus 1x?
B is the number in front of the x, isn't it?
Yeah.
Isn't that what A, B, and C usually stand for? Look, AX squared plus BX plus C. A is in front of x squared. X is x. Got nothing to do with A, B's, and C's. So for you guys, I wrote X is in there. Well, two things, I guess. Two things. This is what I would like you to realize in your exam if you make that mistake. The question says find K. You're going to have K's and X's. That's really overkill. You're going to get yourself super confused. You're going to be like, wait, what's happening here? So, yeah. And then the second thing is obviously what I just said. Yeah, A, B, and C are coefficients. So they don't have X's. Okay, and then K squared plus 6K plus 5 less than 0. And then at this stage, I know how your teachers have taught you guys, but I know how I taught it as well. I make it equal to 0. Your teachers made you draw it and stuff like that. It's not the method that we chose. We've done it differently. K plus 5, K plus 1 equals 0. K equals minus 5 minus 1. Number line, minus 5 minus 1. Open circle. We test. K equals to 0. Always sum it back into the original, which was this one before you made it equal to 0. So is 5 less than 0? Is 5 less than 0? No. So that means over here it does not work. That's where 0 is. Look, it doesn't work.
Why is it open circle?
Why is it open circle? Because it's less than, not less than and equal to. So open circle just means, yeah, not equal to. And then 5 is less than 0. There it is. Because those don't work, which means this guy must work. How do we write that? Minus 5 less than K less than negative 1. Minus 5 less than K less than negative 1. I feel like you guys need to do another one. Am I right with that?
Yeah.
Okay. Try the top one then. If that letter's confusing you, just make it into a K. It's lambda, but just make it a K. There you go. For what values of K does it have equal roots? What are you going to do for equal roots? Discriminant. Equal roots. It has the one root. They're the same root. Equal roots means that the two roots are the same. No real roots. Go. Try to solve for A and B. The answer should be 1 and negative 11. Okay, did we get it out? Tiana, you got -1, -11 and 1?
Yeah.
And then have you done the no real roots bit?
Yeah.
You tested and you saw that the answer should have been -11 less than k less than 1.
I didn't write it like that. I wrote K.
Oh, did you write it like this, the interval notation way?
I just wrote K with -11 and K.
For A. For A, you would write k equals -11 and +1.
I was talking about the no
That's
real
equals. I'm talking about the no real roots now.
Okay.
Because technically when you made it already equal to 0, you're not going to redo everything because you already know it's equal to 0. You just draw a number line. Right?
Yeah.
Do you get what I'm saying?
Yeah.
And then open circle because they're not equal to. Test k equals 0. And what's the equation you had before you solved? What was the equation?
For the
For A. Well, before you solved for -11 and 1. What do you have? Just before you solved. One step before you got -11 and 1. Why are you looking at the question?
No, because I don't be nice then.
But to do B, you had to have done A. Because B is less than 0. Whenever you're doing less than 0, we've made them equal to 0 anyways.
I just done B squared minus 4AC.
That's correct.
Subbed in.
Correct. So then you did k plus 5 squared minus 4 times 9 equals 0.
I got, then in brackets I got K plus 11, K minus 1.
Just straight away? After this line, you got k minus 11?
K squared plus 10K minus 11. Oh, okay.
Yes,
Yeah.
correct. K squared plus 10k minus 11. Yeah, and then from there, yeah, no, that's what I wanted, that line before.
Okay.
All right. That line there, you would sub in it for less than 0 now, because it's not solving for equal to 0. So subbing k equals to 0 into here, you guys will get -11. Is -11 smaller than 0? Yes, so that means 0, which is between these two, works, so they're meeting. The answer is -11 less than k less than 1. You get that? No,
I understand.
didn't do it.
No.
So you want to do it again then?
Yeah.
Another one, so not good at this yet. Show that the roots of this equation. Show that the roots of this equation are real. Show the roots are real. No, that's not what we want. That's not what we've been doing. All right. I'll make it up. Find k if 3x squared plus 2k minus 2x minus 3x minus 2 equals 0 has I 1 root, double I, 2 roots, triple I, no roots. So in other words, to find 1 root, you make your discriminant equal to 0, 1 root, 2 roots, you make your discriminant greater than 0, no roots, less than 0. But they're all still discriminant, so you should have the same answer. So once you do I, you shouldn't be too far off to get double I and triple I. All right, do you want to try that one now? Go. Really hoping to do some logs as well. The functions are a lot bigger.
Same.
Yes.
Is the 3x supposed to be a free float
Say that again. Oh,
at the end? Yeah.
that should have been a K. Thank you. Otherwise, there'll be a big problem, wouldn't there? You can't have X's in there.
What is the x in front of the 2k minus 2?
3x squared plus 2k minus 2x minus 3k minus 2.
So when somebody,
So this would be your A, this would be your B, this whole thing becomes your C. Because it's got no x's, that's the idea. So your formula is B squared, like this, minus 4 times A times C equals to 0. Then you expand. 4k squared minus 2 times 2 is 4 times... Wait, any questions about that line? Let's get that clear. Anyone have any questions about this line? 4k squared minus what did I say? 8 plus 4. Is that right? Minus 12 times this. Let me know if I've made a mistake, please. Or if something's confusing you. Plus 36k plus 24. 4k squared minus 8 plus 36. Minus 8 plus 36 is 28. Positive 28k plus 28 equals 0. K equals, let's see if it works out. Now we use, how do we solve this? How do we solve this question? You obviously need to use the quadratic formula. K equals minus B plus minus square root B squared minus 4 times A times, so 4 times 4 times 28 all over 2A equals 28 squared minus 4 times 4 times 28, 336. So the answer is negative 28 plus minus root 336 on 8. So as long as k is either that plus case or the minus case, this question, this one that I just made up, will have how many roots? 1 root. Do you understand? So as long as k is either of these two, it will have 1 root. As long as k is either of these two, plus or the minus, it will have 1 root. Do you guys get that now? All right. What I'm going to do is also find this as a decimal place, because it's a bit easier to do when you're testing. So minus 28 plus root 336 divided by 8 is negative 1.2. Minus 28 minus root 336 divided by 8 is negative 5.79. Okay, at this case, I asked you to find me double I. 2 roots. If you're trying to do 2 roots, you know that the discriminant has to be greater than 0. So essentially, if you look at this line here, it's just not going to be that. What's it going to be? Greater than 0. Right? Which you've already solved. You've already solved for us right here. Negative 1.2. So k is negative 1.2 and negative 5.79. What do we do now? Number line. There's your negative 5.79 There's your negative 1.2. What am I going to test? K equals 0. Sub it into here. 0 plus 0 plus 28. Is 28 bigger than 0? Is 28 bigger than 0? Yes, so that means, where's 0 here? Right here. It works. That's an open circle, which means this won't work, which means this will work. So how do we write that? K is bigger than this, K is smaller than this. Simple. So your answer for double I should be, instead of being equals, it would be K is greater than negative 1.2, K is less than negative 5.79. I think you guys get the idea. And then if it has no roots, what are you going to say? The discriminant must be less than 0. So instead of this line that I've written up here, which I've written greater than 0, what would you change it to? Less than 0. So when I come up here and I said test K equals to 0, and then is 28 smaller than 0? You'll say no. So does this work? No. So instead of them running away, what's going to happen? They're going to meet. There's only 3 solutions. It's either it is them, it is these. They either run away or they meet. I, double I, triple I. That's it. But all 3 require you to at least do this, to do the one root case. Because that's how we do it. And then we just test. So for triple I, your answer is K is between negative 5.79 and negative 1.2. So the answer for triple I would look something like this. 5.79 less than K, less than negative 1.2. All right, what else in here? Cubics. The whole part, this is what we just went through. Yeah, we just did them. I like it. I like it. All right. Then circles, semicircles, obviously are square rooted. Do we need to do another one of these center radius questions? No. Maybe. Exponentials. Yeah, we'll do an exponential graph. When sketching, try to show 2 points on the curve so then you can make sure you haven't drawn your graph wrong. Y equals half x. Y equals half x. Y equals 1 to the x on 2 to the x. 1 to the power of anything is just 1. And what can I rewrite 1 on 2x as? Think of calculus. It might help you.
2 to the
1
power
on
of negative x.
2 to the power of negative x. So that one's actually sneaky. It's just this one here, just written in a different way. And how do we draw these exponentials? Well, the original exponentials this way, at 1. 2 to the negative x is not negative of this, not negative of the blue. It's just your x is negative. So that swaps it the other way around, not flips it. It's a rotation about the y-axis, not the x-axis. That is 2 to the negative x. So be careful. Let's try this one. Sketch this graph. Y equals negative 2 to the x plus 1. Well, again, maybe a few things. If I was doing this in my exam, the first thing I would do is substitute, x is 0. 0 plus 1 is 1. I know I get a y-intercept of -2. So when x is 0, y is -2. At least I now know that. That's one thing. Then maybe if I absolutely didn't know anything else, I would sub in 1, 2, 3, 4, 5 for x, and same thing for negatives, and then maybe plot it out. So let's do that. Let's do worst case scenario. I'm gonna make sure in your exam, if you guys absolutely couldn't do nothing, at least you know you could just do table values. So let's just quickly go here. Because I get worried about you guys. You don't try things. So what I'm worried about is in your exam, you also won't be used to just trying it out. There you go. All right. I'm going to sub in -2. So -2 plus, -2 to the power of -2 plus 1. That's -half. Then at -1, it should give me -1. At 0, we said it gives me -2. At 1, it gives you -4. At 2, it gives me -8. And at 3, gives me -16. All right, let's see. So at -2, it gave me -half. At -1, it gave me -1. At 0, it gave me -2. At 1, it gave me -4. You guys think you know the shape now? At 2, it gave me -8. At 3, it gave me -16. Can you see the shape? Because you should know how an exponential looks like. And then if you wanted to, if you're not sure if this is going to cut through, if you're not sure if it's going to cut through, if it's going to cut through, that would have an x-intercept, correct? An x-intercept meaning y equals to 0. So 0 equals -2 to the x plus 1. At this stage, you would bring the negative over, which doesn't do nothing in this case. Then you're going to log both sides. Can you log 0? Can you log 0? Because so you can't actually log 0. You'll see it says math error. So you know you're not going to have anything there, which means now you just worked out that's an asymptote. And boom. That wasn't too hard. I need to know that in your exam, worst case scenario, you guys are going to do that. Instead of look at something, maybe the way you guys saw that and go, I don't know what to do. Look, worst case scenario, go back to your basics. Get them out, at least you'll get full marks. And then you can start working on those skills. Okay. All right. Then we got to our hyperbolas. Same thing. What can x not equal to? 2. Your denominator can't be 0. So just be aware of that. So like this one here, straight away, what can x not equal to? -1. And then what can't y equal to? No. Nope.
-2.
Nope.
3.
3. Y can't equal to 3. The reason y can't equal to 3, what does a +3 do to the graph? Shifts the whole thing up 3. So +1 shifts the whole thing to the left 1. That's why you have an asymptote there at -1. +3 takes my whole graph. The original one's on the line here, but you're going to shift the whole thing up 3. So your new asymptote's there. What does a negative do? Instead of it being this way, it's this way. But you would already know that because if you had drawn the other way around, I'll just again show you guys, if you ever did a mistake, it's okay. You drew that. You would have said x is 0. 0 plus 1 is 1. You would have had a y-intercept of minus 2 plus 3, which is 1. Y-intercept of 1, which means I drew my black one just a bit wrong. But there's your 3. That looks like a y-intercept of, let's say, 4. So you know that wouldn't work. If you have a y-intercept of 1, there we go. Y-intercept of 1, which is underneath your 3. So your green would have never worked, is what I was trying to show you. Cool. And then obviously once you've got your y-intercept, you would also do the same to find your x-intercept. When y is 0, you solve for it. And that is all the functions. So I think from today, you guys just learn what bit your week at with functions. Again, I'll go back over this booklet and redo the questions, redo the concepts. Don't leave them too far. I will do logs again next week, because your exam should be in week 10, if I'm not wrong.
Next Thursday.
Next Thursday. Oh, that's not fun.
Are you having any classes this week?
Yeah, you'll have, but it's going to be on Thursday though. It's going to be on Thursday. I know it's too late. I'll see if I can move